Welcome to the video for essential idea number 3 in our nuclear chemistry unit. And this covers a topic that a lot of you drifted into in day 1. So when you were doing essential idea number 1, essential idea number 2 in your research, a lot of you brought this up. Here's the idea of this. Fission has been presented to you. So fission is the decomposing of atoms. This fission can either be spontaneous or through bombardment. The process produces energy, and it also produces smaller nuclei. In addition to fission, there's another energy-producing process, and that's fusion. And that's when you combine two nuclei to make a larger nucleus. And so the best example of that, and the example for which it is nice to have some understanding of, is the process that gives us energy from the sun. And that process is a fusion process. So that really is the only fusion process that I'm going to talk about here, and that's going to be the one that I encourage you to do a little bit of research into. So most basically, the fusion process in the sun takes hydrogen atoms and makes helium. And I have here a overly simplistic equation for it. So there are hydrogen atoms. I've got two hydrogen atoms on the left. We're going to fuse those together. Now one just has, they both have one proton, and one hydrogen atom just has the one proton. That's why its mass number is 1. This second hydrogen atom has a proton. That's what makes it hydrogen, but it's also got a neutron. That's why its mass number is 2. And simplistically, if you fuse those together, you now have a nucleus with 2 protons, so I can't call it hydrogen anymore. I have to call it helium. And from a mass number standpoint, the mass number is now 3 because it has 2 protons and 1 neutron. And then lots of energy is released from that fusion process. In reality, the process is multi-step and more complicated. And I include this image just to highlight that. So as you do a little bit of research into this, you may be coming into terms that are beyond the scope of what we're looking to do here. So the simplistic equation that I had above really captures this part where we have 2 hydrogen atoms, one being hydrogen 1 and the other being hydrogen 2, so to speak. And then I have this presented at the end. I have this part right here. So I'm just creating a small part of this process when I do my equation up above. But to learn a little bit about the sun and how the energy of the sun is created for us, I think that's a worthy goal. The other part of this essential idea number 1 is we've learned about splitting atoms, releasing lots of energy, and we've learned about fusing atoms, releasing lots of energy. So those seem like opposite processes. So one might wonder, how is it that we can have both fission and fusion releasing energy? And so this graph below starts to defend that a little bit. In no way can we become experts in nuclear chemistry on this. But I think trying to answer the question of how both splitting an atom into smaller atoms and fusing 2 smaller atoms to make a larger atom, how can they both release energy? And so what we see on this graph is the x-axis is mass number. And we see that this graph has a peak to it, and then it drops off. And so certainly mathematically, we are familiar with graphs that might have a maximum. So they climb up from one side, achieve a maximum, and then start to decrease on the other side. So that's what we're seeing here. And what we learned from this, and with a little bit of additional study we can confirm, is that there's a part of this graph that's labeled fission, and there's a part that's labeled fusion. And so it's larger atoms that tend to split apart. So we've talked about uranium, right? Uranium is a larger atom, and it is capable of being, under the right conditions, of being split into smaller atoms. So that's really the fission process, that as you make smaller atoms, you're sort of proceeding leftward on this graph towards this optimum point up here. Fusion is really the domain of smaller atoms, and the one example we've talked about there is with 2 hydrogen atoms forming helium. So under the right conditions, as atoms fuse, they're starting small and becoming larger. So you're really riding this portion of the graph right here. So let me summarize what we've just learned there. If we're bothered by the fact that splitting an atom, such as uranium, into two smaller atoms can release lots of energy, and fusing atoms, like two hydrogen atoms to make a helium atom, can release lots of energy. If we're bothered by those seemingly opposite processes, both resulting in energy loss, the additional understanding that fission, or the separating of atoms, is really the domain of the larger atoms, and fusion, two atoms combining into one, is really the domain of smaller atoms. That satisfies that apparent contradiction. That concludes the overview of essential idea number 3. Potential research topics for this essential idea could be either looking at how the sun produces energy for us, or looking more into this so-called binding energy in the nucleus. Thank you.